Hey everyone, let's jump right into today's explainer. As your technical lead, I'm briefing the team today on a massive architectural evaluation we really need to undertake. We have to fundamentally adapt our architecture because, frankly, our documentation is no longer just for human eyes. It's actively becoming the core infrastructure that powers everything else we do.
Right off the bat, we need to confront something known as the documentation deficit. The reality of our modern development cycle is that our continuous deployment velocity, shipping code weekly, sometimes even daily, has completely outpaced our ability to write and update manuals by hand. Think about it. If we're only building static web pages for human developers to read, we're basically missing half the picture.
So here is our game plan for this architectural evaluation. We'll be covering the documentation deficit, automating pull request updates, designing for AI agents, analyzing agent traffic gaps, and wrapping up with native versus third-party layers. Let's get into it. Section 1, the documentation deficit and AST parsing. Let's look at exactly how we overcome traditional AI failures.
To really understand this paradigm shift, you have to see why traditional AI retrieval fails on complex code bases. You know how standard retrieval augmented generation, or RAG, works? It cuts up code files using arbitrary character limits. It's literally like taking a chainsaw to a function just because it hit 1,000 characters. It completely destroys scope boundaries. But modern tools, they use abstract syntax tree, or AST parsing. This is a total game changer. It maps the exact bi-directional relationships between our controllers, services, and repositories, maintaining the true structural hierarchy of our code.
Moving right along to Section 2, automating pull request updates and stopping docs drift. Because these tools have that deep, semantic code-base understanding we just talked about, we can use them to completely automate our workflow. Tools like Mintlify and Promptless treat our documentation exactly like code. When an engineer pushes a commit, a webhook fires off. Then, a workflow AI agent reads the semantic code diff, autonomously drafts the necessary markdown updates, and just opens a pull request for human to review. It stops documentation drift right at the source. And it doesn't stop at text updates. We can completely automate our architectural diagrams and API integration features too. Tools like Codicate and DocBot scan our repositories and auto-generate complex mermaid architecture diagrams. And no, these aren't just generic templates, they map our actual code imports. Plus, for our APIs, we get auto-generated OpenAPI and async API reference pages. You get these interactive API playgrounds that sync directly with the backend implementation in seconds. So your live testing is never out of sync. All right, Section 3, designing for AI agents. This is really the climax of our briefing, where we look at a completely new class of user. Get this, the data shows a massive turning point. Nearly half of all documentation traffic now comes from AI coding assistants like Cursor, Claude Code, and ChatGPT. If our docs aren't optimized for these autonomous readers, literally 50% of our audience is getting degraded, unstructured data. We just aren't only writing for humans anymore. To properly serve these agents, our platform has to generate some very specific files. First, there's LLM's text. Think of this as a structural sitemap built specifically for large language models, telling them exactly where to find our core logic. Then we have SkillMD, which gives explicit instructions on what our docs help those agents accomplish. Add in clean markdown that bypasses messy HTML, and you get super reliable, hallucination-free AI ingestion. Even more importantly, we need to talk about the Model Context Protocol, or MCP. This is absolutely crucial. By hosting an MCP server, an AI agent sitting inside a developer's IDE can query our live documentation in real time. It doesn't have to rely on stale training data from 6 months ago. It grabs our automated markdown, those mermaid diagrams, and live API specs the very second a developer asks a question in their editor. Now, Section 4, analyzing agent traffic gaps. If we're treating documentation as active infrastructure, we have to measure it like an API. Modern analytics platforms are finally separating human readers from AI agent traffic. While human metrics look at standard stuff like IP addresses and bounce rates, for AI agents, we track the specific agent name, like Cursor or Claude, and the actual programmatic queries they run. Most importantly, we track their failure points. We want to identify those exact queries where an agent struggled to retrieve data so we can proactively patch those documentation gaps before a human developer ever notices an issue. Finally, Section 5, native versus third-party layers. Let's talk about evaluating the tooling market. As your technical lead, here's how I think we should weigh our options for our existing repositories. You've got native AI platforms like Mintlify or Gitbook that give you bidirectional Git sync, native open API playgrounds, and they automatically generate those critical MCP and LMS.txt files. They are designed to replace your entire stack. On the flip side, third-party retrieval layers, like Kappa, essentially patch RAG and chat capabilities onto what we already have. You get search, sure, but no live API testing or native architectural diagram generation. Honestly, for a highly technical architecture, native platforms offer a much more robust ecosystem.
I really want you to take this quote to heart. When developers are your primary customers, your documentation is the product. It just hits the nail on the head. It perfectly reinforces why documentation has to be an integrated, automated part of our continuous development cycle, not just an afterthought we rush through at the end of a sprint.
So I'll leave you with a provocative thought today. If AI agents are becoming our primary readers, consuming AST-parsed code, auto-generated mermaid diagrams, and real-time MCP feeds, will traditional documentation writing actually become obsolete, or is it simply evolving into pure system architecture? Think about it. And hey, if you found this explainer helpful for your own team's architecture, be sure to like, share, and subscribe. Catch you next time.